18. You wish to have $3,000 in 2 years. So this is a future money. To buy a fancy new stereo system, how much should you deposit each quarter? So it's not one-time deposit. So it's deposit each quarter. So that means we need to use annuity formula. Right, annuity formula. Let's recall the formula. So we have Pn, in this case, we have 2 years. So P2 equals to deposit, right? Deposit each quarterly. Well, let's identify variables actually. So we have P2. So in 2 years, we wish to have $3,000. Then how much should we deposit now? We're trying to find it. The account paying 8% interest, which is 0.08, compounded quarterly. Okay. So K equals 4 because 4 quarters in a year. Okay, now let's recall the formula. The formula is Pn equals D multiplied by a fraction, right? The denominator in the fraction is R divided by K. The numerator is 1 plus R divided by K, then raised by NK minus 1. So this is the annuity formula. So let's calculate two numbers first. Let's calculate R divided by K. Or, you know what, let's put everything in. So we set up the equation. Because P2, the future money in 2 years, that's how much we wish to have, $3,000. That's our goal. And D, we have no idea. We're trying to find. Then the numerator is 1 plus R is 0.08 divided by quarter, K equals 4. Then raised by N times K. Well, N is 2. I didn't write down N. N is 2. K is 4. NK means N multiplied by K. So 2 times 4. Then minus 1. Then divided this by 0.08 divided by 4. Okay, so this is set up. If you can set up like this, you already get half of the total points. Now we need to calculate this. Right? 0.08 divided by 4, this is 0.02. Well, we can rewrite the equation. I'm trying to find a D. So I have 1 plus 0.08 divided by 4, that's 0.02. Of course, you can use a calculator. 2 times 4, that's 8. Then minus 1. Then divided by 0.02. So we want to calculate this number. So again, if we want to write an equation, we keep writing it. So we want to find this D. D is 1 plus 0.02, which is 1.02. Raised by A minus 1, then divided by 0.02. Well, let's do this on the decimals. Right? Or another way I could do this, because it's only raised by 8. So I could do on my simple calculator to do 8 times. So multiply 1.02 times 1.02. So 1.02 times 1.02, I get 1.0404. Now I can multiply by this number, because this one I'm thinking 1.02 raised by 8 is the same as 1.02 squared raised by 4, right? So I can multiply 1.0404 to get a 1 point. You know what? I don't remember all these numbers. Let's just do 1, 2, 3, 4, 5, 6, 7, 8. It's a multiply 1.02 8 times. Right. So when I do not have a scientific calculator, I only have a simple calculator. That's one way I could do it. So rewrite 3,000 equal to D multiplied by, I got a 1.17166. Let's round up to this. Then minus 1. Then divided by 0.02. So this side, we keep writing this. Now 1.17166 minus 1, I get a 0.17166. Then I divide by 0.02. So minus 1, then divided by 0.02 to get a point. Write down this number. So I have 3,000 equal to D multiplied by 8.5A 296. So let me round up to 3. Now I need to divide both sides by, so basically D equals to 3,000 divided by this number, 8.583. So I get 3,000 divided by 8.583 to get 349.528. I round up A to 2, so get it 53. So the deposit is $349.53. So let's go back to the question. So in order for me to get $3,000 in 2 years, with an interest rate 8% compounded quarterly in the account, I need to deposit $349.53 each quarter. All right. So what have we done? First, we identify the variables. Right. Identify the quantities given, the data given in the problem with corresponding decimal, with a corresponding variable. Right. So we have identified P2, our future goal is $3,000. So this is future money. And how much to deposit each quarter, we don't know. The interest for the account is 8%. And because the compounded quarterly is K equals to 4. Then we know to use annuity formula because it's a continuing deposit because we deposit each quarter. So this tells us we need to use annuity formula. So identify the variables, we plug into the formula, then to calculate. When we calculate, if we cannot put everything in the calculator, we do step by step. Okay, we calculate the exponent first. We calculate also inside the parentheses first. Then in the end, we get the deposit. So we should deposit each quarter deposit $349.53, about $350. All right, that's annuity formula.